We'll start with the first one. What is this one called? It's confusing. I mean, there's not a number there. This is greater than. I started with greater. Sorry, that's maybe confusing. Or maybe another way you might hear it is more than? Sure. That's just some phrases you might look out for. When we are graphing on a number line, and I'm going to pick some hypothetical value a instead of picking a real number. If I'm graphing greater than, then it is not equal to, so it needs to be an open circle at a going to the right, because going to the right on a number line is where the numbers get bigger. Interval notation, I said nothing is new today. That's only partially true, because interval notation is probably new for you. I like interval notation. We use it a lot in Algebra 2. You look at the left side, see the red graph here? We're looking left, right. On the left side is A. On the right side, you need to think about where is it going to. Where is it going? If you look at a number line, we're at a number and we go to the right, where is it headed? It's not any distinct number. What is it? Infinity. You see the right side of the graph, how it's going to positive infinity? That's where it's going. So if it's going from A to the right, then it is going from A to positive infinity. Since A is an open circle, we use a parentheses, because that means that I can't plot a point at A. I also cannot plot a point at infinity because you just can't. Okay, so we always have parentheses at infinity. Okay, here's your next line. We're going to go faster now. Less than. Another phrase that you might hear? Fewer than. That was a good one I heard earlier today. My 5th hour. Fewer than. The graph looks pretty similar. I'm going to use A again because I am. Which way should I go? To the left, to the left. That's what Beyonce said. Okay. Such a good song. The Queen. Okay, we're going left, right. What's on the left side this time? Negative infinity. And it's going up to the right. A. Okay, so it's left, right. It goes from negative infinity, because if you look at my number line over there, that's what's on the left. Do you see it? Negative infinity up to A. Again, you can't plot a point at A because it's an open circle, and you can't plot a point at infinity because it's infinity. Okay, we are missing our friends or equal to, so let's get those in the fun here. We're going to kind of do them at once. This is your greater than or equal to, less than or equal to. So I'm just going to say or equal to. Hopefully you know that part. This is your wow, I'm sorry. Greater than or equal to. Or you might hear at least. That'd be another good phrase. And then less than. I don't know why I wrote it in 2 spots. Less than or equal to. And this one would be at most. I don't think this really belongs here. I'm going to move it. Okay. Okay, so your graph's basically the same, right? What's the difference on this graph? Closed circle. Nice. I'm calling it B this time for the sake of making it a little different. So greater than or equal to would be a closed circle and to the right. Less than or equal to, you should have a closed circle and to the left. So you know this. If you draw your graphs a little different than mine, it doesn't bother me. You can do a squiggly arrow or do it on the number line. That just stresses me out. I don't do it. That's why I do it above. Okay. And your interval notation, again, pretty similar. So this B goes from the greater than or equal to goes from B to infinity. Here is the fun difference. because it's a closed circle, you need to have a bracket at B. It's like a rectangular E without the middle line. And then it's a parentheses at infinity. Still. The other one goes from negative infinity to B. You still have to have parentheses at infinity, but then because B is a closed circle, B gets the bracket because that means it includes. So that's our way of saying it. Closed circle is the same thing as bracket. Little reminder that you always use parentheses whenever you have an infinity sign. And I am going to run out of room. Parentheses with infinity, both with positive infinity and negative infinity. For interval notation, please, okay? Parentheses is THESES. Okay. We're going to do number 1 together. You'll do number 2 on your own. Number 1, x is greater than or equal to 8. What kind of circle do I have at 8? We should probably label 8 first. I'm pretty lazy, and I just put 8 in the middle of the graph, and I don't bother labeling any other numbers, and if you do that too, I think that's great. Okay, if you want to add more numbers because you like to fill it all in, that's fine. It is closed at 8, and it's greater to the right. So your interval notation goes from, on the left side, you've got 8, and on the right side, you've got infinity and beyond. Yes. What kind of thing is it? 8 parentheses or bracket? It's closed, so it's a bracket. And infinity gets a parentheses. -1. If you multiply or divide by a negative, there's something special you have to do. Anyone remember? That's okay. If you multiply or divide by a negative on both sides of the equation, you have to flip the sign. Flip the inequality symbol. Like literally reverse it. If that word makes more sense to you, then do that. You're not going to see it on this front page. You'll see it on the next page. And then I will always pretty much ask you to graph it. Sometimes I'll have you do it by hand and make your own number line. Usually not, but sometimes. We're going to do the more interesting one together, number 2. And then I'll have you try number 1. I usually still draw the little bouncing line down the middle because I like that. You don't have to do it. Okay, you are still using that don't call me after midnight. We don't have any distribution. We don't have any like terms. So now we're going to move the variables to one side. Olivia, what do you suggest? Move 6. Let's subtract it. She gone. 2n plus 2 less than or equal to -9. Okay. Let's now subtract 2 and get -11. If you show your work here, the fraction should be right in front of your face. Because when I divide by 2, I see it right there. Wow, -11 over 2. Show your work and you will know which number goes on the top. So I will still usually ask you to write your final answer and box it, even though you are going to graph it on a number line. Sorry, I'll zoom in a little bit. A lot of it. Let's graph it. If you would like to fill in the extra stuff on the number line, you can, right? You'd have -6 and -5 surrounding this because it's -5.5. But I'm just going to put -11 halves here and make that be good enough. What kind of circle? Open, close. Closed. Because it's or equal to and it is less. So when I go to do interval notation, I'm thinking, okay, left, right. On the left, it's going to negative infinity, and on the right, negative 11 halves. So negative infinity to negative 11 over 2. And that's parentheses, but negative 11 over 2 is a bracket. What happened? Oh, it disappeared for a second. That was weird. 5. Please check with each other. Make sure you got the same thing, especially so that you can check my work and see if I'm actually correct. Disregard the question, what is a compound inequality? That's for another day. Okay, let's go. You can draw your balancing line still. And let's move the variables to one side since I don't have anything to simplify. So I'm going to subtract 3D. And get negative 1D minus 2 is less than 8. Now what, Finley? Yep. Negative 1D is less than 10. Carson, what's my last thing?
You're going to divide by -1.
And this is the moment you've been waiting for your entire life. Because now that you've now that you've divided by a negative, you get to do something very special. In a second. Flip the sign, okay? 10 divided by negative 1 is negative 10. You are not flipping the sign because you get a negative answer. You are flipping the sign because of what I highlighted in green, which you can hardly see. Let me make it blue. Maybe that will help. Mildly. Okay. Yes. You've multiplied, oh my gosh, again, divided by a negative on both sides. Because you divided by a negative on both sides, you are flipping the sign. It was like this. Now it is like this. If you need to make a note so that you don't forget it, I divided by a negative on both sides. Yep. Yep. This moment right here. Okay. Let's go ahead and graph it. So it's greater than. So your interval notation, try that. I think that's right. If you simplify this inequality and distribute and combine like terms, which I'll do in one step. I've got like terms here. Distribution. You should get 8x minus 6 is less than or equal to 8x minus 6. Something fishy is happening. You notice anything? It's the same. Let's say you didn't notice it and you just carried on. If you move your variables to one side and they cancel, negative 6 is less than or equal to negative 6. But is it? This is true because it's equal to. And what do you think we say? Infinite solutions or all real numbers? I'll take either. It matters more. I told you you couldn't say it the other day. I think it makes sense. I decided. Okay. Because when you go to graph it, what's it going to look like? It's all of it. It's the entire number line. Okay? And that's why all real numbers make sense, I decided. Is because it's the entire number line. Any number you plug in will make it work. And so you are okay, which means that when you do your interval notation, it's literally, yes, negative infinity to positive infinity. Okay?